Okay, this is the FET that I actually took out of the that was actually shorted, and as you can see, we'll just I'll just show you. It's actually shorted all the way around. Okay, and I did replace that and the open resistor, which should be right in this area here. Okay, this is the bottom of it, the bottom of the FET there, right there. Okay, right here, and as you can see, that's good. It's no short there. Okay, you can see my meter there or not, but yeah, this is no short there. Okay, so it is good. Okay, so that lets me know that there's nothing, supposedly there's nothing else, there's no short across that trace anyway. Okay, and of course I did check a few other things, like I checked this diode here also. Get my other glasses here. Checked where we at here. Now that dial was reading short. Okay, I'll flip it over. It's actually this diode right here. And this dial was, of course, we're checking pretty good. Okay, and sometimes I notice on some power supply boards they will use a diode in conjunction with the switching mode transformer, and sometimes it'll read short or low resistance. So I kind of figured, well, maybe maybe that's the way it's supposed to read. And then after I replaced the MOSFET, and I plugged in the power supply, I noticed I still wasn't getting my standby voltage. Okay, which means I did have another problem somewhere. Okay, so what I did is as of course you can see, I got my, I don't know why I use green, but I got my green, my black negative ground going to the hot ground. Okay, which is located at these are the three big filter capacitors across here, and if I put it, as you can see, that's one capacitor I've got it connected to, the negative side. They're all connected. Okay, so like I said, do not use the negative side of the AC core, because you will get a false reading. Always go to the big filter capacitors, the negative side of the filter capacitors. If you cannot access it from the top, if you're checking the top part of the board, you can just always go to something that's connected to the negative side, like this here. This is a coil here, or a jumper wire, and just go on top and connect your lead there for the hot side of the ground. Okay, so now I'm going to put my meter to voltage, and we're going to do a few checks here and see what the heck's going on. Okay, now like I said, once again, anything on this side of this line, this symbol, which is also on top, it's white on the bottom, it's colored black on the top, is hot ground. Okay, so of course I'll go to this FET down here that we replaced. And I'll see we have any voltage there. DC volts, okay. We don't have anything there. We do have something here on the output side here, but there's nothing on these other ones. There's no type of drive signal or anything. There's just no voltage there at all. Okay, and in order for that to work, you must have a color on or a bias voltage, however you want to call it, to actually make that work. Okay, so actually this is probably coming from a source. This is actually, where am I at here? Okay, yeah, so this output side. I believe this is the drain or source. I get those confused, but the voltage is there, okay, but it's not doing anything but the voltage to drive the transformer, okay. And quite naturally, we know this because there's nothing on that side, and there's nothing on this side, okay. And we do have voltage. I'm just going to go right here so I won't short anything out here. We do have voltage there, okay, on this side here. And if we actually go to our caps, okay, I'm pretty sure we have voltage there also, okay. So we'll just go to the positive side of the capacitors, okay. And there's our 158, okay. So yeah, so we do have AC input to the board, but we just don't have anything coming down here to drive the rest of the circuit and to produce our standby voltages. Okay, so actually what I did here is, let me unplug it here. Unplug it first, okay. Make sure, do not touch your fingers, even when it's unplugged, across those capacitors. Be very careful because you will get a slight shock, okay, and you will hit something that will scare the shit out of you. Okay, so what I did is I actually started checking other components. And like I said, that diode was still reading short. And I went to the bottom of the board here, okay. Let me go ahead and mark this so you know this is the. I'll put the location number in the on the video or in the description of this this FET right here that we replaced. Okay. Okay, that's the FET there replaced. Okay. And as you can see, once again, there's no short there. Okay, so that is good. Okay, but like I said, when that diode on the other side was shorted, I started doing some further investigation after I still didn't have my standby voltage, and this is the pretty much the power, what they call a power factor correction circuit. Okay, as you can see, I made a few other checks down here, and I noticed that this capacitor was reading short. Okay, so I actually took that capacitor out, checked it. It was good. Okay, and I had a short still across the trace. So I started doing further investigation. Of course, the diode next to it was shorted. Okay, this diode here was reading good. Okay. Once again, that diode was reading short. Okay. This is the other diode that's reading short. Okay. And so I was like saying, that's a lot of shorts. So then I went to these are what they call Optocouplers, okay? And as you can see, I'm going to just flip this around for you for 1 second. These Optocouplers here, as you can see, we got 2 pins on the primary side and 2 pins on the secondary side, okay, on the hot cold ground and hot ground, okay. And basically what that does, the reason they call them Optocouplers is because if anything on these 2 pins here sense a problem with the circuit here, whether it's too much voltage or over current, it's actually a little photo transistor that lights up inside of each one of these, and when it lights up, it's going to shut this side is going to shut this part of the power supply off. Okay, it shuts the power supply off because there's too much current. Okay, so if there's a short or anything, then of course the little light inside of these optocouplers will light up and then tell the secondary was there's nothing happening, shut this bitch down. So shut it down, okay? So pretty much. So what I did is I went across the pins on these, make sure, because sometimes you will have a shorter one. It's been a while since I've had that one. And look at that. Now, I know for a fact that's not supposed to be right because it's going to shut down. Okay, so let's just flip it over. And this was the actual bad optic coupler right here. Okay. That is not right. One proof, here we go again. That's not supposed to be shorted. Okay, so I actually did pull it out. I pulled it out. I'm sorry, I pulled it out. Read good. Still read it short across this trace. So the next thing I'm beginning to think of, okay, well, I checked a few other components around here. I got too many shorts there, point blank, period. So what I did is I went to hot ground and checked this out. This is pretty much, I believe this is the power factor correction IC. It's either this one or this one. But this is actually the controller IC for the transformer, for the switcher transformer, okay? And what I did is I actually went to hot ground again. I'm still on the diode checker, and I went to see how many grounds I have, or how many short, if there's anything shorted on this IC, because that's my next suspect, right? Okay, reading a short there. Uh-oh, read another short there. Okay. Okay. That is way too many shorts on a 8-pin IC. Okay, right? Okay, we got short here. Another one. We'll go up top here. Okay. And as you can see where I was grounded at, right on the negative side of the capacitor, because we are still in the hot ground. Okay, that is way too many shorts. Okay, so the next thing that I want to do is, because I'm figuring, well, it could be the IC itself, or it could be something else, maybe like this diode or something, one of these other components that could be shorted. So what I actually would do is I would actually get the, I don't know if you can see the part number on there. I can hold this camera steady. Okay. Let's loosen you up a little bit. So we can zoom. See, oh, I lost it now. All right, man. Hold on. Let's see. Where we at? There we go. I'm trying to zoom it in so you can actually see the actual part number on here. As much as I can there. Okay. Well, of course, it's upside down. Let's try this again. Okay, there we go. It's much better. Okay, that is actually a TEA 1733. Tango Echo Alpha 1733. Controller IC. Switch mode controller IC. Okay, so what I did, because I don't have a schematic, I don't know what's ground, what's supposed to be ground, what's supposed to be the VCC to power it on, I went to the internet and pulled up a pinout or a data sheet on the IC. And basically all that involves is just going to Google, put in the Google search box TEA 1733 and click, and you're going to see a bunch of little links to some specs and data sheets on it. And that's all we did. And I'm going to give you an example of just how I did that right here and found out what the problem was. Okay? Okay, this is basically all we have to do is just go to Google, put in the part number of the controller, and be able to find the data sheet or the pinout. We'll just go up to the second one here, green chip. Okay, pretty much gives you a description of what it is. Come down some, make sure you have the right, make sure it looks like the one you have, 8 pins. That's the right one. And the main thing, and this is the pinout, which is the most important thing. So if you don't have a schematic, this is like the best way to do this. And we'll check our ground. Okay, as you can see, we've only got like one ground, looks like. Okay, now one of these other circuits, one of these other pins may be, biased to ground, but looks like we just got one ground here, which is pin number 2. Okay, and this, of course, pin number 1 is obviously the VCC. So basically, we want to check. First thing we want to check is pin number 1 and pin number 2, and make sure that that's not shorted together, because the pin number 1 should definitely not be shorted because it is the VCC. Okay, and as you can see, these are all. It gives you all the description, symbol, description, what it's used for. Okay, so basically, what this IC does, it pretty much controls the switching transformer. It'll actually shut it down, shut the power supply down if it senses an overdrive of current or voltage. Okay, so kind of like acts like a electronic fuse, pretty much. And before I get out of this one, I just want to show you the okay. Then it also has a circuit that is pretty much in, and you can actually check and see if anything else is pretty much biased to ground, which it does not look like. Maybe the iSense may have a low reading. As you can see, ground is going right to ground. VCC, of course, obviously is not going to ground. Okay, it's coming back from the transformer here. The second winding on the primary side is going to VCC. And that's producing your VCC via this dial right here. Okay, and as you can see, there is a Optic Coupler right here. Okay, which once again I said, if this is a overcurrent if this is overcurrent, just so we have one here, and we also have one here. If this is any overcurrent, the actual photo transistor inside is going to light up, okay, and shut the circuit down. Okay, so obviously we did have a short on one side of one of these optocouplers. Okay, this is not the exact circuit of the TV, but this is a sample circuit that this will be used in, and as you can see, it's obviously controlling the switch mode transformer as far as safety or whatever. Okay, and it gives us some more stuff down here. So it's really a pretty good thing to do if you do not have a schematic. So it's just like a sub or whatever, substitute for it without a schematic. And just while we're here, I'm actually going to go over to the actual MOSFET that was shorted. And when you guys are replacing these MOSFETs here, basically this is the part number. Usually the last 2 digits, C70, stands for the voltage rating. Okay, it's an N channel, 700 watts. I'm sorry, 700 volts. Okay, 8.6 amps. Now, if you, I've done this. I have some MOSFETs. If you have a MOSFET that has, maybe like almost the same number, or it might be a SCP-12, NK70, or NK80, which is 800 volts, you can actually go a little higher and sub it in, as long as the voltage rating is the same or maybe higher, and the amperage. You get 8.6 amps. Now, maybe that's what the 10 stands for, up to 10 amps, I'm not sure. But you can try that. It won't do any damage, it won't hurt, as long as it's a N channel, not a P channel MOSFET, okay? And this also is Xenon protected, okay? So, and as you're going to scroll down, it'll give you, this is the package that it's in, the TO-220. That means the actual shape of the MOSFET, okay? The package, okay? And to give you some more information, parameters and values on it, okay? And just like I said, I just put the part number in so I can raise this up here or something. I guess not, huh? Oh, come on. All right, well, I just went to Google and put the part number of the MOSFET in, and the same thing I did with the controller IC. And that's pretty much about it. Okay, so okay, so obviously we from looking at the pinouts on the IC on Google, we should only have one ground, okay, which is pin 2, and pin 1 is the VCC. That's the voltage that is used to actually make the IC work. Okay, so it needs the VCC. That's the source voltage. And we'll zoom in on the IC one more time if I can do this correctly. Okay. And as you notice, there's a little, where are we at? Okay, there's a little arrow right here. Okay, a little triangle there, and that's considered pin 1. So we got pin 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's how that goes. Okay, so I'll do this once again. We'll check pins 1 and 2. That is unacceptable. That is not correct. So what we're going to do now is going to actually pull the IC off of the board. And we'll see if any of those shorts go away. If those shorts go away as far as the capacitor and the other thing, the diode, then we know the IC, that, and of course on the Optocoupler, where was that at? There's one right here. If the shorts go away on especially on these 2 pins after we have the IC removed, then we know that pretty much that was our problem. Okay, so now we're going to remove. We're going to just add a little hot air to it. Just put my hot air on about 400 degrees. That should be enough. And see, that fairly easy. That came right off. Okay. As you do see, we do have some little pads up under it, but they're not exactly. Come on. We have some little pads up under there, but they're not actually metal. I think there's actually some glue there on the bottom. So now what I'm going to do again is I'm going to check once again the capacitor and of course the optocoupler. Okay, now here's the optocoupler that was shorted. One little arrow pointing to it. Aha! Short went away. Okay, I'm going to recheck the little diode that was next to it that was reading short, which is right here. And the capacitor. Short is gone. No short, no short. I'm going to check this diode again that was on top, was reading short. It's good. Okay, so that, folks, was our problem, pretty much. Okay, so I do happen to have another one, a brand new one, whatever I did with it, right here. Okay, so we'll replace that and we'll see what happens, okay?